Here's the lab report for the Bouncing Balls lab, and the first part is the introduction and the objective. So the overall purpose of this experiment was to observe how different factors such as the ball type or the contact or the surface that the ball comes in contact with or the drop height and other factors affect the bounce height and the energy loss of a ball. But to make our experiment more purposeful and more specific, we chose just to focus on the type of ball that was being dropped. So we came up with our hypothesis that a super ball, or a ball that's way more bouncier, would lose less kinetic energy since it's more likely to rebound closer to its initial height rather than a regular ball. And we came up with this hypothesis because it kind of resembled an elastic collision where all of the kinetic energy is conserved. So that's why we decided to use this principle of physics and apply it to our experiment in order to determine if the bouncier ball will lose less kinetic energy and, of course, bounce back to its original height. So here is our design of our experiment. So some of the materials we used was a meter stick to measure the drop height. We also used a slow motion camera to record the person dropping the ball. And we also used a video analysis app where we were able to plot the points and determine the position of the ball at different locations. And then we used a scale to measure the masses of the balls. And the two balls that we used were a normal ball and a super ball. So the normal one was less bouncier than the super ball. And here's our setup as shown here. So here's a little bit more in depth about how we actually conducted the procedure. So first we measured the mass of each ball using the scale, and we recorded that in our lab notebook. And we also positioned the meter stick against a wall and made sure it's in frame for recording, and it's also straight up against the wall, so it's not inclined, or it's not like it's up against the wall completely. That way it doesn't interfere with the results of our data. And then next we started recording, and we dropped the first ball, which was the rubber ball, or the super ball, which was the rubber ball, at a height of 1 meter. Then we uploaded this video into Vernier Analysis at 60 frames per second, and we started plotting the points of the position. Next, we repeated this for the super ball as well. So the same thing, we dropped it from a 1 meter height. And then next, we repeated step 3 for both the balls, but we changed the starting height to 0.75 meters. And then again, we repeated step 3 for both the balls, but this time the starting height was 0.5 meters. And after uploading all the videos and collecting the data using the video analysis app, we put this data into a data table. That way we were able to visualize the loss of kinetic energy at each height and each ball. So here are some videos that show our process. So this first video is us dropping the ball at the height of 1 meter. And the video was in slow motion when we put into graphical analysis, and we only used the first bounce. That way we were able to measure when all of the potential energy is converted into kinetic energy. And then next we have us dropping the ball from a height of 0.75 meters. And the final video is us dropping the ball from a height of 0.5 meters. And now moving into how we controlled all the variables in our experiment. So we had several ways or several factors that helped us control the variables. So first of all, we only dropped the ball from rest That way we could observe how all of the potential energy was being converted into kinetic energy. And we were able to analyze what the change in kinetic energy was. And then we also had the same person drop the ball each time. That way we were able to consistently measure the drop height from the meter stick. And we kind of supported this by having the same person record record our experiment from the same exact location. That way we were not moving the camera up or down, and we weren't changing the overall angle at which we viewed the experiment. And finally, we also conducted 3 trials per drop height. That way we could ensure that our data was without any human error, or as minimum of human error we could get it to be.
The experiment investigated the elasticity and energy conservation of 2 types of balls, a rubber ball and a super ball when dropped from varying heights. The findings revealed that as the drop height increased, the initial and final velocities of the balls also increased, consistent with the conservation of mechanical energy. However, neither ball exhibited perfectly elastic behavior, as changes in kinetic energy were observed in all trials. The super ball showed smaller changes in kinetic energy when compared to the rubber ball, which shows its greater elasticity. The calculated impulse, determined by change in momentum, demonstrated that higher velocities resulted in greater impulses, aligning with the principles of impulse and momentum. These results support the hypothesis that collisions with higher initial velocities deviate further from being perfectly elastic, with momentum conserved in all cases.